Spiral galaxies. When most people picture a galaxy, they imagine a spiral, and it's no surprise why. Spiral galaxies are the most iconic and visually stunning structures in the universe. With their swirling arms, glowing stars, and bright cores, they look almost too perfect to be real. These galaxies are made up of a flat, rotating disk containing stars, gas, and dust, with distinct spiral arms curving outward from a central bulge. But those arms aren't solid structures. They're more like waves of density, where stars and gas bunch up temporarily. As gas clouds pass through these denser regions, they collapse under gravity, sparking new star formation. That's why the arms are lit up with bright, blue stars. They're stellar nurseries. At the core of most spiral galaxies is a dense bulge of older, redder stars, and likely a supermassive black hole lurking silently in the center. Surrounding the entire system is a massive dark matter halo, invisible but essential. It provides the extra gravitational glue that keeps these galaxies spinning faster than they otherwise should. Spiral galaxies come in different styles. Some have tightly wound arms, others more loosely defined ones. Many even have a bar-shaped structure running through the center, earning them the title barred spiral galaxies. These bars may help funnel gas into the center, feeding both star formation and black hole activity. Our Milky Way is one such barred spiral galaxy, and it's not alone. Roughly 2/3 of all observed galaxies are spirals. They tend to be younger, gas-rich, and full of stellar activity, making them some of the most dynamic systems in the cosmos. Spiral galaxies may be beautiful, but they're also temporary. Over billions of years, interactions and mergers can distort them beyond recognition. But while they last, they're cosmic masterpieces in motion. Elliptical galaxies. If spiral galaxies are the graceful dancers of the universe, elliptical galaxies are their quiet, massive cousins, older, more mysterious, and far less flashy. These galaxies don't have elegant arms or blazing young stars. Instead, they're vast, smooth clouds of ancient stars, shaped like spheres or elongated ovals. Elliptical galaxies are some of the largest in the universe, stretching hundreds of thousands of light years across. But despite their size, they're surprisingly uneventful. Made up mostly of old, reddish stars, they contain little gas or dust, meaning star formation has mostly stopped. These galaxies have already passed through their energetic youth, and now drift quietly through time. Their structure is simple. No spiral arms, no bright core, just a featureless glow. The stars inside move in random directions, giving them their blob-like appearance. Ellipticals come in all sizes, from small dwarfs to giant ones anchoring galaxy clusters. Most formed from galactic mergers, massive collisions that scrambled stars into disordered orbits. Those violent origins might explain their now settled look. While they may not sparkle with activity, elliptical galaxies are cosmic archives. Packed with dark matter and old stars, they hold clues to the early universe and remind us that sometimes stillness speaks volumes. Lenticular galaxies. Imagine a galaxy caught in cosmic limbo, too structured to be elliptical, but too quiet to be a spiral. That's a lenticular galaxy. It has the disk and bulge of a spiral, but without the graceful arms or star-forming fireworks. Instead, it's filled with older, redder stars and very little gas, making it largely dormant. These galaxies often live in dense clusters, where gravitational forces strip them of gas and distort their structure. Despite their inactivity, they play an important transitional role, bridging the energetic youth of spirals and the settled stillness of ellipticals. And while they may not be dramatic, lenticulars are visually stunning when viewed edge-on, thin, silver and sleek like cosmic coins floating in space. They don't demand attention, but they hold a quiet significance. Lenticular galaxies are the calm after the storm, silently preserving the shape of what once was. Dwarf galaxies. If galaxies were cities, dwarf galaxies would be the quiet little towns, small, unassuming, but full of cosmic importance. While giants like the Milky Way boast hundreds of billions of stars, dwarf galaxies may have only a few million to a few billion. Yet, despite their modest size, They're the most common galaxies in the universe. These tiny galaxies are everywhere. Some orbit larger galaxies as satellites, like the large and small Magellanic Clouds circling the Milky Way. Others drift alone through space, undisturbed and ancient. They come in many varieties: dwarf ellipticals, dwarf irregulars, dwarf spheroidals, and range from active star formers to faded relics of the early universe. What makes them especially interesting is their role in the grand scheme of things. Astronomers believe larger galaxies grew by merging with smaller dwarfs. In that sense, dwarf galaxies are the building blocks of the universe. Studying them also gives insights into dark matter, galaxy evolution, and the conditions of the early cosmos. So while they might not steal the spotlight, dwarf galaxies are essential to the universe's story. They're small but mighty, the cosmic underdogs quietly shaping everything around them. Peculiar galaxies. Imagine a galaxy caught in a cosmic collision, twisted, stretched, and reshaped by chaos. That's a peculiar galaxy, the rule breakers of the universe. Unlike the classic spirals or ellipticals, these galaxies don't fit neatly into any category. They're often the result of violent galactic encounters, collisions, mergers, or gravitational disruptions that leave behind stunning, bizarre shapes. Some peculiar galaxies still show hints of their original form, while others are completely transformed. Take the antennae galaxies, two spirals mid-crash, flinging stars outward in long arcs. Or the cartwheel galaxy, struck so precisely it now resembles a giant wheel in space. These aren't just eye candy, they're snapshots of cosmic upheaval. Peculiar galaxies are more than just odd shapes. They're sites of intense star formation, where massive clouds of gas collide and trigger stellar explosions. These galaxies help astronomers study how galaxies grow, merge, and evolve over time. In a universe that usually favors structure and balance, peculiar galaxies are reminders that disorder can be just as powerful and just as beautiful. They show us that even in the vast order of the cosmos, chaos has its own kind of elegance. Active galaxies. What if a single object could outshine an entire galaxy? That's the reality of active galaxies, where the heart of the galaxy burns brighter than all its stars combined. At the core of these galaxies lies a supermassive black hole, not just sitting silently, but feeding. As gas and dust spiral into the black hole, they heat up and form a glowing disk that blazes with energy, sometimes brighter than the rest of the galaxy itself. This intense energy can shoot out as jets, stretch across space, and beam in radio waves, X-rays, even gamma rays. Depending on how we're looking at them, we call these galaxies quasars, blazars, or Seyfert galaxies. But they all share the same dramatic engine, a ravenous black hole lighting up the cosmos. Many active galaxies are also incredibly distant, yet still visible across billions of light years. Quasars, for instance, are among the farthest objects we've ever seen, bright enough to study from the early universe. These galaxies aren't just flashy, they're clues. By studying them, we learn how galaxies evolve, how black holes grow, and what the young universe looked like. They're chaotic, extreme, and utterly captivating, the showstoppers of the cosmos. Irregular galaxies. Imagine a galaxy that doesn't follow the rules. No spirals, no smooth ellipses, just cosmic chaos. That's an irregular galaxy, the rebels of the universe. These galaxies lack any clear structure or center. Many are the aftermath of galactic collisions or gravitational run-ins with larger neighbors, leaving them twisted, clumped, and scattered. Some look like cosmic wreckage because they are. But don't let their messiness fool you. Irregular galaxies are hotspots for star formation. Rich in gas and dust, they're home to massive young stars that light up clouds of gas, creating dazzling displays in ultraviolet and infrared light. Two famous examples are the Large and Small Magellanic Clouds, irregular galaxies orbiting the Milky Way. Visible from the southern hemisphere as faint smudges, they are dynamic and active, slowly being torn apart by our galaxy's gravity. Irregular galaxies also offer clues to how galaxies form and evolve. Some were once spirals or ellipticals distorted over time. Others might still be forming, piecing themselves together in the cosmic dark. They may not fit neatly into categories, but irregular galaxies remind us that the universe isn't always tidy, and that some of its most fascinating stories lie in the chaos.